Quantum computing isn't just some sci-fi theory anymore. It's a real conversation happening in boardrooms right now. And the big question everyone's asking has changed from if it'll create value to how do we actually make money from it. So let's dive in and connect those dots, from these wild algorithms to actual real-world dollars.
And get this, the stakes are absolutely massive. McKinsey is predicting that by 2035, quantum computing could create trillions, with a T, trillions of dollars in value. We're not talking about a small improvement here. This is a potential earthquake for the global economy. So where in the world does all that money come from? Well, it all starts with what quantum computers can do that normal computers just can't. We're talking about solving a very special class of problems, the kind where the complexity just completely explodes and our best supercomputers just give up. So let's break down what's really happening here. A classical computer, the one on your desk or in a data center, it tries to solve these huge problems one step at a time. And as the options grow, it just gets bogged down until it hits a brick wall. It just can't keep up. But a quantum computer, it plays a totally different game. By using bizarre quantum effects like superposition, where a qubit can be a 1 and a 0 at the same time, it can look at a massive landscape of possible answers all at once. It's not just faster, it's a fundamentally different and, frankly, a much smarter way of looking at the problem. Okay, so one of the most important tools in this new quantum toolbox is something called QAOA. The best way to think of it is as a bridge between the computers we have today and the quantum future. See, it's a hybrid, which means it cleverly uses both. The quantum computer does the really hard part, the heavy lifting of exploring all those possibilities, and a classical computer helps it fine-tune the answer. It's basically designed to work with the kinds of quantum machines we actually have right now, which are still a bit noisy and not quite perfect yet.
Okay, so that's the theory, but let's make this real. Where is this technology actually starting to look like a genuine competitive advantage? Well, one of the first and most developed places is Wall Street, specifically in optimizing investment portfolios. And why is this such a perfect problem for a quantum computer? Because building the perfect portfolio is an absolute beast. You're not just trying to balance risk and reward. You have to deal with all these messy, real-world rules. Like, you can only buy whole shares of a stock, not half a share. You've got transaction costs. You've got complex government regulations. For a classical computer, every single one of these rules you add makes the problem exponentially harder until it just grinds to a halt. And this is where the rubber meets the road. A 5 to 10% improvement in something called the Sharpe ratio, which is just a key way to measure how much return you get for the risk you take. That is a huge deal in finance. This isn't just a guess. Even on today's simulators, it's showing a clear, measurable quantum advantage on a really high-value problem. So, a better portfolio is amazing, right? But any good business leader is thinking the same thing. Value is great, but it always comes with a cost. So that leads us to the billion-dollar question, or maybe the trillion-dollar question. This is the moment, right here, where all that abstract theory hits the company's balance sheet. For the longest time, nobody really knew what this stuff would cost. It was all academic, but not anymore. Now that you can actually rent time on a quantum computer in the cloud, we have real price tags. So, how do they charge you? Well, it all comes down to something called a gate shot. That's just one basic operation on a qubit run one time. Now, this formula from IonQ might look a little intimidating, but don't worry, it's actually pretty simple. It's just a minimum fee plus a tiny charge for each 1 qubit and 2 qubit operation you do, multiplied by the number of shots, which is how many times you have to run the program to get a reliable answer. And here they are, the actual real-world numbers. We're talking fractions of a penny for a single operation. Now, the key thing to understand is that while each little step is cheap, a really complex algorithm that you have to run thousands of times, well, it adds up. You can see the minimum price to run a single program is about $100 if you turn on error mitigation. The bottom line is, the price of quantum is no longer some big secret. We can actually calculate it. Okay, so we've got a clear model for how this works in finance. We see the value and we know the cost. But this story is way bigger than just Wall Street. The exact same ideas apply across so many other massive industries. I mean, think about logistics. Trying to figure out the absolute best route for a delivery truck with just 50 stops is an unbelievably hard problem for a normal computer. Or what about manufacturing? Figuring out the perfect schedule for machines on a factory floor to cut down on wasted time? These are billion-dollar efficiency puzzles that quantum is perfectly suited to solve.
Or take a look at healthcare and pharmaceuticals. Here, it's less about optimization and more about simulation. Quantum computers have this unique ability to perfectly simulate molecules in a way classical computers could only ever dream of. This could totally revolutionize how we discover new drugs, maybe by finding the perfect molecule for a new medicine, or even just by creating super accurate data to train our AI models to find new drug candidates way faster.
And that right there brings us to a really key point, the powerful connection between quantum and AI. Quantum isn't here to replace AI, it's here to supercharge it. It can speed up the hardest, most time-consuming parts of training an AI. Or, like we just saw, it can create incredibly high-quality data that helps our machine learning models become way more powerful and accurate than before. So, you put it all together, we have clear applications, we have transparent pricing, and so the whole conversation for business leaders is changing. It's shifting from what is this weird quantum thing to what's our strategy for it? And the decision to invest is becoming less about next quarter's ROI and more about long-term survival and staying ahead of the curve.
Right, and this is maybe the most important takeaway of all. We have to reframe the question. If your biggest competitor develops a quantum advantage that gives them even a 10% edge in their supply chain or their portfolio returns, what does that do to your business? Suddenly, the cost of doing nothing could literally put you out of business. It's less of an investment and more like strategic insurance.
But listen, this doesn't mean you have to go and bet the entire company on quantum tomorrow. The smart way to do this is with what's called a stage gate model. You start small. You run a few low-cost experiments on a cloud platform to test one specific idea. If it works, if it shows promise, great. You pass through the gate and you invest a little bit more. It's a fantastic way to explore what's possible without taking on a crazy amount of risk. And zooming out one last time, this isn't just about what one company does. For this whole quantum economy to really take off, we need a healthy ecosystem around it. That means smart regulations that encourage innovation, clear technical standards so all these different systems can actually work together, and a real commitment to being responsible to build trust with the public. You need these foundations to build a stable market. And that's where we land. For the very first time, we can actually put a price tag on a quantum computation. We can see its real, tangible value in everything from finance to drug discovery. So you see, this question isn't some far-off, abstract thing anymore. It's a strategic calculation, and it's one every leader needs to start making right now.